Today, we're diving into a really cool new AI framework called MemRL. And the goal here is, well, it's pretty revolutionary. It's all about letting an AI learn from its own experiences, a lot more like you and I do. So let's get into how they're trying to crack one of the biggest challenges in AI. Think about this for a second. When you're learning a new recipe and you accidentally burn the onions, you don't need a full software update to figure out, hey, maybe I should turn down the heat next time. You just learn. So why has it been so unbelievably hard to get an AI to do the same simple thing? And that question, it gets right to the heart of a massive learning problem in AI development. It's a fundamental dilemma that this new system, MEMRL, was built from the ground up to solve. What we're talking about is something researchers call the Stability-Plasticity Dilemma. Now, it sounds super technical, I know, but it's really just a simple trade-off that has seriously held AI back from learning and adapting in the real world. See, the problem breaks down into two really bad options. On one hand, you've got stable AI. Its knowledge is locked in place, it's super reliable, but it can't learn a single new thing without a massive, expensive, and time-consuming retraining from scratch. Then, on the other hand, you have plastic AI. This one can learn, but it's kind of like a leaky bucket. As new information comes in, it can just overwrite and destroy the old knowledge. It's a huge issue called catastrophic forgetting. So you're stuck, right? You either get an AI that can't learn or one that can't remember what it already knows. So how in the world do you get the best of both, the stability and the plasticity? Well, the researchers behind MemRL looked for inspiration from the absolute best learning machine we know of, our own brain. The research paper itself puts it perfectly, I think. It says our intelligence isn't about a brain that's constantly rewriting itself. No, it's about a delicate balance between our stable core knowledge and a super flexible memory for new experiences. New episodes in our lives. And it turns out our brains already have this system totally figured out. You've got the cortex, which holds our stable, long-term knowledge, like how to ride a bike. And then you have our episodic memory, which handles all the new stuff. What you had for breakfast, a mistake you made at work, a new fact you just learned. MemRL is designed to copy that exact blueprint for an AI. So the solution, when you think about it, is surprisingly elegant. Stop trying to constantly rewire the AI's core programming. Instead, you just freeze its brain and give it a totally separate, evolving memory that it can learn from. Okay, so that's the big idea. It makes a lot of sense, but how does this thing actually work? How does MemRL figure out what to remember? The whole setup is really clever. First, you've got the main large language model, the LLM. It is completely frozen. Its programming is locked, which means there is zero risk of that catastrophic forgetting we talked about. Then it's hooked up to an external memory that's always changing and evolving. That's its flexible, episodic memory. And here's the kicker. All the learning happens in the memory, not in the core model itself. And the way these memories are stored is pretty cool too. It's not just a big dump of data. Every single memory is what they call a memory triplet. You can think of it like a smart note card that has three key things written on it. The intent, which is what the AI was trying to do, the experience, which is what actually happened, and a utility score, which is basically a grade for how helpful that experience was. This simple structure creates this amazing continuous learning loop. It all starts when the AI gets a new task. It instantly searches its memory for the most useful past experience it has. It uses that memory to come up with a solution, and then it gets feedback from the real world. Did it work or did it fail? And finally, and this is the most important part, it updates the helpfulness score for that memory. If the solution worked, the score goes up. If it failed, the score goes down. Simple as that. That utility score, which researchers call a Q value, borrowing from reinforcement learning, that is the absolute secret sauce here. It's a living, breathing rating that lets the AI figure out over time which of its experiences are actually valuable and which ones are just noise. This is how the system literally learns to remember what works. So the theory sounds brilliant, right? But the million-dollar question is, does it actually work when you put it to the test? Let's take a look at how it performed. Researchers put MemRL through some seriously tough challenges. In one of the hardest ones, a complex navigation task called ALFWorld, the results were, well, they were pretty staggering. An AI with no memory at all, it succeeded less than 28% of the time. The previous best AI that used memory got up to about 46%. But MemRL? It blew them both away with a success rate of almost 70%. Just to be crystal clear, that's a 56% relative improvement over the last best system. This isn't just a small incremental tweak. This is a massive leap forward in what these AIs can do.
So why is it so much better? What's going on under the hood? Well, the secret is that MemRL learns to become what the paper calls a trajectory verifier. Because its helpfulness score is based on the final outcome of a whole series of actions, it doesn't just learn to pick a memory that looks good for the first step. It learns to pick memories that lead to success across the entire journey, from the very beginning all the way to the end. This is a pretty significant breakthrough. So let's zoom out for a second and really think about what this could mean for the future of AI. So why does MemRL matter so much? For starters, it offers this beautiful, elegant solution to that stability-plasticity dilemma that's plagued AI for so long. It means an AI can finally learn from its experiences without the huge cost and risk of a full retraining. This allows AI agents to adapt safely in real time. Honestly, it's a huge step towards creating an AI that learns in a way that's much more familiar, much more human. And that leaves us with this one kind of mind-bending final question. Until now, most of our powerful AIs have been basically identical copies of each other, all trained on the exact same giant dataset. But MemRL opens the door to AIs that can learn and evolve based on their own unique individual experiences. So, what happens then? What happens when you have two AIs that start out exactly the same, but go on to live two completely different lives? What will they become?